Section 2.3, Additional Displays of Quantitative Data. The objectives in this section, you will be able to construct frequency polygons, create cumulative frequency and relative frequency tables, construct ogives, and draw time series graphs. Okay, so in this section we continue to organize and summarize quantitative data by presenting additional displays commonly used in statistical analysis, stem and leaf plots, frequency polygons, cumulative distributions, ogives, and time series graphs. Now for the first objective, number 1, we're going to draw stem and leaf plots. In a stem and leaf plot, or stem plot, we use the digits to the left of the rightmost digit to form the stem, and each rightmost digit forms a leaf. So for example, a data value of 147 would have 14 as the stem and 7 as the leaf. Now for example, we're going to constructing a stem and leaf plot. The data in a table below represent the percentages of persons living in poverty by state in 2015. We want to draw a stem and leaf plot of the data. So the first thing we're going to do in step number 1 is we're going to treat the integer portion of the number as the stem, meaning all the numbers to the left of the decimal is going to be treated as the stem, and then the decimal portion as the leaf. So for example, the stem of Alabama will be 16 and the leaf will be 3. So let me go ahead and highlight that. So again, we have the stem of Alabama will be 16. So there's Alabama and there is the stem. And then the leaf will be 3, and we can see that 3 is going to represent the leaf. Now, the stem of 16 is also going to include all the data from 16.0 to 16.9. So what that means is we have to find all the 16. So there's another 16, there's another 16, another 16. And let's see here. Do we have any more? Looks like that's all we have. And then we would say that this 1 is also a leaf, this 6 is also a leaf, and that 2 is also a leaf. And then in step 2, you're going to write the stems vertically in ascending order and then draw a vertical line to the right of the stems. Because the lowest data value is 7.3, if we take a look here, okay, the lowest data value, okay, so the lowest data value is 7.3, and if we take a look here, that's where it is assigned to New Hampshire, okay, and then we can see that the highest data value is 19.7. So if we look at the highest data value at 19.7, okay, so we're going to let the stems range from the following numbers. We're going to let it range from 7 to 19. So I want to take a look here. So on the left hand side, we have our vertical line. We have 7, 8, 9, 10, 11, 12, 13, 14, all the way down to 19. So again, this is going to represent our stem. Okay, so let's start with 7. So with 7, we want to take a look at all the stems for 7. So if we look at each one of those, we have a 7 here for Minnesota. We have a 7 for New Hampshire. And so we have 0.3 and 0.8 as the leaf. So if you take a look here, we have 3 and 8 as our leaves. Okay, now we're going to take a look at the stem where it is 8. So if we take a look at our data, we're going to find all the stems that have 8. So if we take a look there, we do not have anything with a stem of 8. So therefore, the leaf is going to be blank. Okay, now we're going to look at 9. So we have a stem of 9 here, another one here, another 9 there. We have a 9 there, another 9 there, and another 9 there, and a 9 there. And so now we're going to look at the leaves. So we have 2, we have a 9, and we have a 1. And then we have a 6, and then an 8, and then a 3, and another 8. So we also have to make sure that we include where it is double. So I want you to take a look at the stems here. We have 1, we have 2, we have 3, we have 6, and then we had 2 8s, and then a 9. So therefore that represents 9.1, 9.2, 9.3, all the way to 9.9. Okay, now we're looking at the next stem, which is 10. So we have here 10.9, another 10.9, 10.4, 10.3, 10.7, 10.7, and 10.9. So we're going to make sure that we include all the repeats. So the leaf has 2 9s there. It has 3 total 9s. We have a 4, we have a 3, and we have 2 7s. So going from smallest to largest, we have 10.3, 10.4, 10.7, 10.7, 10.9, 10.9, 10.9. Okay, the next stem is 11, so let's take a look at 11. So we have 11 here, another 11 there, another 11 there, another 11 there, another 11, there's the other, there, and then there. And let's take a look at the leaves. So we have a 1, we have a 5, we have a 9, we have a 2, we have another 9 which is repeating, we have an 8, 4, and a 4 repeating. So if we take a look here, we have our 11.1, we have our 11.2, we have 2 11.4s, we also have an 11.5, an 11.8, and 11.9, and 11.9. Okay, now let's take a look at another stem, which is 12. So we have here 12, another 12, another 12 there, 12 there. And so let's take a look at the leaf for 12. So we have a 0.3 here, we have another 0.3 there, 0.8, 0.3. And so it looks like we have 12.3s listed 3 times and a 12.8. Okay, let's take a look at the stem for 13. So we have 13.9, 13.5, 13.0, 13.6, and 13.9. And then if we take a look at the leaf, we have a 9, we have a 5, we have a 0, 6, and a 9. So if we take a look at that, we have 13.0, 13.5, 13.6, and 2 13.9s. Okay, now let's take a look at the stem for 14. So we have 14.2, 14.2, 14.2, 14.3, 14.7, 14.7, and 14.5. So looking at the leaves, we have a 2, we have another 2, which is 3, 2 7s, a 3, and then a 5. So we have 3 14.2s, 1 14.3, 1 14.5, and 2 14.7s. Let's take a look at the stem for 15. So we have a 15.3, and it looks like that's all we have, with the leaf being 3, so we have 15.3. Let's take a look at the 16s. So we already looked at the 16s. we had 16.3. We also had a 16.1 and a 16.3 and a 16.6 from the beginning when we were looking at step 1. So there's 16.3, there's 16.1, 16.6, and 16.2. Let's take a look at 17. So do we have any stems that are 17? Well, we have a 17, and then we have a leaf of 2. So therefore we have 17.2, we have one of them. And then 18, we have a stem there, another stem here, and it has a leaf of 1 and 6. So therefore that's 18.1 and 18.6. And our last stem is 19. So we have 19.5, 19.1, and 19.7 with a leaf of 5, 1, and then 7. So therefore we would then have 19.1, 19.5, and 19.7. Okay. Now the following steps summarize the method for constructing a stem and leaf plot. In construction of a stem and leaf plot, step 1, the stem of the data value will consist of the digits to the left of the rightmost digit. The leaf of a data value will be the rightmost digit. Step 2, you're going to write the stems in a vertical column in increasing order, and then draw a vertical line to the right of the stems. Step 3, you write each leaf corresponding to the stems to the right of the vertical line. Step 4, within each stem, rearrange the leaves in ascending order, title the plot, and include a legend to indicate what the values represent. So if you look here, here is the particular stem and leaf plot. Now sometimes the steps listed for creating stem and leaf plots must be modified to meet the needs of the data. So stem and leaf plots versus histograms. Notice that a stem and leaf plot looks much like a histogram turned on its side. So what I mean by that is, okay, let's take a look at this stem and leaf plot here. If I rotate this, okay, this looks like a histogram. Okay, now bringing it back, we can see what it looks like in its regular form. So the stem serves as the class. So for example, the stem 10 contains all the data from 10.0 to 10.9. The leaves represent the frequency, the height of the rectangle. So therefore, it is important to space the leaves evenly. Now, one advantage of the stem and leaf plot over frequency distributions in histograms is that the raw data can be retrieved from the stem and leaf plot. So, from a stem and leaf plot, we can determine the maximum observation. We cannot learn this information immediately from a histogram. So, refer to the figure below here, which shows a histogram of the poverty data that is drawn in StatCrunch. Now, we can see that the largest observation is between 19 and 19.9. But we don't know what the largest value is, or we don't know that the largest value is 19.7, which is clear from the stem and leaf plot in the below to the right. So, on the other hand, stem and leaf plots lose their usefulness when the data sets are large or consist of large range of values. Now we also have what we call our split stems. So the data in the table below, okay, range from 11 to 48. So if we look at this here, figure A here on the left shows a stem and leaf plot using the tens digit as the stem and the ones digit as the leaf. The data appear rather bunched. So here we have 11, another 11, and then a 12, a 13, and so on. To resolve this problem, we can use split stems. So for example, rather than using one stem for the class of data 10 through 19, we can use two stems. One for the 10 to 14, which is the first line up here in figure B, and then a second for 15 to 19, which you can see here in figure B. So therefore, this is split stem. So this represents, again, 11, 11, 12, 13, and 14. And then this one goes from 15 all the way to 19. Same thing with this. This goes all the way from 20 to 24. And this one goes from 26 to 29. This one goes from 30 to 32. And then from 36 to 38. And this one goes from 4, in this case, 4, the value of 4, and then 46 to 48. Now, the stem and leaf plot here shown in Figure B reveals a better distribution of the data. As with the determination of class intervals and the creation of frequency histograms, judgment plays a major role in how you present data in a stem and leaf plot. There is no such thing as the correct stem and leaf plot. However, a quick comparison of figures A and B show that some plots are better than others. Okay, so I also wanted to discuss how do you create your stem and leaf plot using StatCrunch. So I'm going to go back to the first example that we had done, which is this one right here. Okay, and what we want to do is we want to draw stem and leaf plots. So the first thing we're going to do is we're going to have our data in StatCrunch. So here is the data that we have in StatCrunch. Okay, and what we want to do is we want to be able to create a stem and leaf plot. Okay, so we're going to go to Graph, and then we're going to select stem and leaf. Okay, and then we're going to select the column that we want, which is the percent, because that's what we want to do, is use the percent. Okay, and then when it says outlier trimming, then we can go ahead and select none. Now, here where it says leaf unit, because we use decimals, we use the leaf to be a tenth. So we would come over here and then select, okay, which one represents a tenth? Well, that would be 0.1. So if we select 0.1, okay, and then select compute, well, now it's going to give us exactly what we have over here. So let me go ahead and copy that, because again, the left unit represents the tenth of a decimal. So that should match what we have here to the left. Okay, now if our leaf was just 1, okay, then it would be a slightly different. Well, not slightly different, a lot different. So let's go back to the options and then to edit. Now if I change the leaf unit to just be the whole number 1, we're going to see that we're going to get a different stem and leaf plot. So it all depends on how we choose what our leaf is going to be.